Hiya, this is a video about the volume of a parallelepiped. As you can see here, this is a diagram of the shape, and the volume is the area of the base of this shape times its vertical height, h. So the target is to find both of these terms in in terms of vectors, so that we can use these vectors b, c and a to find the volume of this parallelepiped. So let's start by trying to express the area of the base in terms of b and c. So let's draw out that base. So it looks something like this. This is the angle theta that you can see there. This is c and this is b. This is two triangles stuck together. So we can use what we already know from geometry. That is, the area of this triangle here is equal to the length of this side here, which is the magnitude of c, times the length of this side here, which is the magnitude of b, times a half, multiplied by the sine of this angle, theta, multiplied by the sine of theta. And since we've got two of them, and these two shapes are exactly the same, we're timesing it by 2, so this goes out. So we know that the area of the base is the magnitude of c times the magnitude of b times sine of theta. Now you may recognize this because you may realize that b cross c, the cross product of b and c, is actually equal to the magnitude of b times the magnitude of c times the sine of the angle between them. So already we're very, very close to what we've got up here, but then times this unit vector, where n is perpendicular to both b and c. Alright, so we've kind of got, so if we just say the absolute value of the cross product of b and c, then we've already got this, the area of the base, in terms of the vectors b and c. So excellent, we're almost done. So that's the area of the base. So next we want to have this vertical height h in terms of the vector a, b and c. And that's obviously because we're looking for the volume of this whole shape, and that is equal to the area of the base times this height here. So in order to get that, we're going to use some basic trigonometry. So you see that this is a right-angled triangle here, and we've got lots of theorems to help us deal with this. So if I just draw out that right here, so you can see what we're working with. That's the right angle there. That's the length that we're trying to find. That's the angle between the two of them. And that's A. So, how can we find H in this setup? Well, the way to do it is that the cos of this angle, remember SOHCAHTOA, is the adjacent over the hypotenuse. And in this case, the adjacent is h, and the hypotenuse is a. So I've got h over a, meaning that our height, our vertical height, is the vector a times the cos of this angle. So now that we know that h is equal to a times the cos of the angle between them, and we know that b cross c is equal to the magnitude of b times the magnitude of c times the sine of the angle between them times n where n is a perpendicular vector to b and c, then we can see that what we need to do is a dot b cross c. And the reason for this is that if we do a dot b cross c, what we've actually got is a dot the magnitude of b times the magnitude of c times sine of the angle between them, which is the area of the base. So you've got a times the area of the base multiplied by the unit vector n, where n is perpendicular to b and c, and so n has the same direction as h, and this is a dot n times the area of the base. A dot n is equal to the magnitude of a times the magnitude of n times the cos of the angle between them. Now, since n is a unit vector, its magnitude is 1, and we've got the magnitude of a times cos of theta, where theta is the angle between a and n, which is the same angle as is between a and h, so this is equal to h. So what we've got here is a dot b cross c is actually equal to h times area of base. And this is the volume. So we've done it. If you've got any questions that you'd like me to go through, I'd be happy to do so. I hope you have a good time and do well in your exams. Thank you.